Pretty straightforward. State the parent function, and you can see the power of 4 is right there, right? So then you know the parent is y equals x to the 4. Okay. And then again, you're just looking outside and inside. So we've got here the vertical, 1, 2, and then inside here is the horizontal, right? And I only have 1 happening there, and there's nothing to factor. So if there's nothing to factor, there's nothing to factor, right? So you can't force it, that's fine. And then it just says state the parent function and describe the transformations. So we're going to say vertical, and it's going to say reflection in the x-axis, right? So it's flipped up and down. And then vertical, and it's going to be a shrink, or you can use the word compression by a factor or by times 2/3. And then the only one here is horizontal, and it's going to be a shift or translation. So translation or shift, and it's right 2. That's it. Okay, so that's a short question. When you're ready, flip over. Okay, we're going to still describe. I find just talking through it and describing it. We won't ask you to describe it every time. And don't describe it if it doesn't ask you to. I'm just doing it so that you keep talking to yourself in your head. Okay? If I don't ask you to describe it, you don't have to, because it'll take a long time to write it down. But in this one, I said to describe it. Apply to the parent function to create the following graphs. We got this one. Rewrite the equation. Describe the transformation. Oh, this one, it is only describe. Oh, this one's only describe, yeah. Okay, describe. Oh, then write the equation. Sometimes I just say write the equation. So if the question says write the equation, you don't have to describe, right? If it says describe, you have to describe, obviously. But if it says write the equation, you don't have to also describe. I'm doing both for our example. Note, the text will combine the horizontal and vertical dilatations. Those are the stretches and compressions. Dilatation is an old-fashioned way of saying stretch and compression. So stretch and compressions, the stretches and compressions, dilatations, they will combine them algebraically and expand and collect. I'll show you what that means on one of our questions on B, right? It's just that the book always simplifies it algebraically. Okay, so first one here. We have a cubic, so we know the parent function is cubic. Oh, in this case, we have to tell you what the parent function is because, look, I don't know if that is x squared or x to the 4, right? We don't know anymore. So now that we know more, last year we didn't tell you because you didn't know there was an x to the, or you did know there was an x to the 4, but you would never have used it, right? So now I have to start to tell you. Same with the x cubed, because that could be x to the 5, right? So now I have to tell you the parent functions. Sometimes you kind of go, hey, wait, you have to tell me now. Yeah, I do. Right, because now you know so much. So here the parent function is x cubed, so we're going to say what happens. The shape of it, all you need is the 1 point, then nothing happened, right? So if it's over 1, up 1, then we know there's no stretch, no compression. So we're going to go straight to vertical, and it's a translation or shift. Translation, or you can say the word shift. And it's going to be right 2. Okay, and then a horizontal, and it's going to be translation or shift, whichever word you want to use, and it's down 2. Those little tick marks underneath mean exactly the same word as above. So that little tick tick means the word above, the word above. Yeah.
Wouldn't it be flipped, vertical and horizontal?
Sorry.
Would it be horizontal right 2 and then vertical down 2?
Oh, shoot, yes, absolutely. What am I doing? Shift, vertical, down. Yes, thank you, thank you. I don't know what I'm doing. Perfect. So vertical down 2. Yeah, I'm saying it, and I'm not even hearing myself, and it's right. Thank you. Yes, so right. Sorry, I said right, and I said vertical. Wrong. Okay, so it's down 2 and horizontal right 2. Thank you. And then you're just writing your equation. So writing your equation would be f of x or y equals, it doesn't matter, we know it's a function, and it's going to be no stretch or compression, so no a value, so it's just going to be x, and it's going to be minus 2 cubed and down 2, that's it. Okay, now, next one. I'm telling you that the parent function is x to the 4, right? So here I told you it's x cubed, so this one's x to the 4. Then we're going to list all of the transformations. So it's going to be, I list the translations last because algebraically we always put them last. It's always a plus or a minus stuff, right? So we've got here, so this will be a vertical, and this will be, now, what do we want to say is happening? So normally it's over 1, up 1. Now, if I hand draw this, please forgive my hand drawing, I will indicate the point. So see how I kind of highlighted that? So don't take any of these tiny points here and go, hey, wait, you mean for, okay? So just take the point that I'm highlighting. I meant for it to aim there. So some people go, but that looks like a half or a quarter. I'm like, don't read those ones. That's me hand drawing it. So take the point that I kind of highlighted. Okay, so I'm sorry about the rest of it. Unless I do it on a computer, you have to take the point I give you. So right there. So you're going to say, and again, we did this last year, so what I usually told my students was that I said instead of over 1, up 1 like that, it was over 2. So I said times 2 horizontally, right? And then up 3, so this will be times 3 vertically. Right, so times 2 horizontally. This is a horizontal stretch by a factor of 2 because it went twice as wide and 3 times as high. We didn't do a lot of doubles last year, but we did show you them. Like sometimes we kept it to single, like either horizontal or vertical, but we did do some with double. So this is both double wide and up 3. So it's 2 times as wide and 3 times as high. Okay, so times 2 horizontally, times 3 vertically. So we're going to say a vertical, and it's a stretch by a factor of, so vertical, 3. The horizontal stretch by a factor of 2. You can use the little tick marks if you want. Okay, so that's my stretch. I'm going to do my shift or translation. So it's going to be a vertical translation or shift, and that's going to be up 2. And it's a horizontal translation or shift, and that'll be left 1. Okay, and no reflection, right? So nothing's been upside down or anything like that. So no reflection. And then for my equation, it would be this. Now, leave a little bit of room underneath this because this is the one where I'm going to show you how they combine a couple things. So we're going to do y equals, or f of x, up to you. Okay, so I know it's a vertical times 3, horizontal times 2. So that means in here, it's 1/2, right? 1/2, so I'll put a little star there. Just be careful, it has to be reciprocal, right? Reciprocal for the horizontal. Bracket, and this will be x minus 2, plus 2, plus 1, left. I'm doing my vertical and horizontals back again. So left 1, so it'll be plus 1, right? Double bracket there. Now watch out here, and we're going to make sure that you put the power of 4 here. You're concentrating so much on the numbers and the signs and the reciprocal. Frequently, people forget the 4. And I told you it was a parent function of 4. It's just kind of a little mistake that you do. You drop it, okay, because you're concentrating on everything else. And then here, so this is up 2, so plus 2. So 1, 2, 3, 4, 1, 2, 3, 4, all there. So don't drop your 4. Yeah.
What did you say those tick marks were?
It means the exact same word as the word above. So just when you're grabbing a word above, it's an old-fashioned way of doing it. I don't know, but I am 1,000 years old. So, we used to just, whenever you put a tick mark, it's like saying the word above, and the word above. You can use that. Someone will have to tell me whether or not anyone on this planet still uses that, or if it's just me. I don't know. Yes.
So if it can be simplified, are we supposed to simplify?
Yes. So that's why I said leave some room here. We're going to simplify.
But
So
that
when
one can't be simplified.
Yeah, but we can algebraically still simplify. So that's what I was saying up here, is that the text always combines all your horizontal stretches and compressions, and they algebraically want you to put it together. Graphically, it would not help us. It would make it 3/16, not good. So graphically, you want it separate, because if I was to graph that, I want them as two separate. But algebraically, the book says, I'd like you to algebraically put it together. So let's practice doing that, because if you don't, all your answers won't be finished. Like, you're going to not be able to check your answers. So 3, okay? And then 1/2 to the power 4. Oops, sorry. Oh, what am I doing today? 1/2 to the power of 4, right? So this 4 goes to both. So that's why the 4. And this is x plus 1. And do I want you to simplify? Yes, I do. So if you're making the equation, I do want you to simplify so we get the same answer. 2 to the 4, that would be 16. And you can do this faster if you can, right? So you can go straight to the 3/16. There we go. Yes?
Do we have to do the first equation, like on a test or something, or can we just do the second?
Yeah, you can go straight to the second. Yep, absolutely. If you can go faster, because you want to get to here anyway. Yep. Yep, and again,
Like, just ignore the horizontal.
yeah, but you can say, well, the horizontal is the 4. So if you can get the 3/16, yeah, you can. Yeah, exactly, right? The more you see it, the more some people are like, I can actually see the factor. Yeah. Yeah, so if you can see the factor faster, you can. Okay, most of the time, people like it broken down, so I'll show it this way.
So you're not using the point 1, you're using point 1.
Yeah, exactly, right? So if you can do it with another point, I just show the 0.11. Yeah. Okay? So yeah, if you can go faster, you can, for sure. All right? You're getting more comfortable with it, for sure. Okay, there we go. And yes, I do want you to finish it. Okay, so when you're doing an algebraic, I do want you to finish it. Graphically, like I said, it depends on whether it's going to help you, if you want to break it apart or not. But here, we always want to algebraically finish it when you're creating the equation. Okay, last one here for the page would be, again, we've got, what do we got? Parent function is x squared. Okay, we're going to describe it. I'm still using the 1, 1 point. Okay, and again, if you can do otherwise, then you can. But here I'm doing 1, 1, so it should be here. But instead, it's going to be over here. So times 1, 2, 3. That's horizontally. And then here, 1, 2, 3, 2, 3 times 5. Is that right? And this is vertical. So 2, 3, 4, 5. So it's a horizontal, and it's reflection. So it's a reflection of a horizontal reflection as well. Okay, so times 3 times 5, 1, 2, 3, 1, 2, 3, 4, 5. Okay, and it is reflected, so I'm going to state all that. So let's put all our statements together and do one more equation. So vertical reflection in the x-axis. Okay, we're doing a vertical, right? Vertical, and this is going to be stretch by a factor of 5. Horizontal, stretch by a factor of 3. And what else? Vertical translation or shift. And it's going to be up 3, and horizontal translation, and that'll be right 2. Did I make any mistakes this time? Keep making mistakes today. I didn't leave a lot of room. Let's do our simplification, though. So f of x, or y equals, and we're going to do, so vertical reflections, are going to negative. Factor by a 5, right? Horizontal would be 1/3. Okay? And then in the horizontal, x minus 2. Okay, square it. Don't forget the squared. and you're going to go up 3, so plus 3. And yes, I do want you to simplify. And if you can do it faster, you can. You know that's going to be squared, so it'll be 1 over 9. 1 over 9 times the negative 5, right? So all I need is this, negative 5 over the 9, right? So if you can go a little faster, so I want to show you one where I went a little faster, that's all I need, right? So that's squared, it's 9, and it multiplies with the negative 5 in front. Didn't make any mistakes this time.